Hey everyone, in this class we are going to focus on what is IR sensors and its working principle, circuit diagram, features, advantages and disadvantages, and what are the applications. Coming to what is IR sensor. IR sensor is an electronic device that measures the infrared radiation. There are two types of IR sensors are available. One is active IR sensor and another one is passive IR sensor. Coming to active IR sensor. These are the sensors both emit and detect the infrared radiation. It's having two parts. One is light emitting diode and another one is a receiver. When object comes closer to the sensor, the IR light from the LED reflects off of the object and it is detected by the receiver. This acts as proximity sensor and they are commonly used in obstacle detection such as robots. Now, passive IR sensor. It only detects the IR radiation but do not emit it from LED. These are used in motion-based detection. Now, let's focus on the principle, how the IR sensor works. In IR sensor, transmitter is a IR LED and receiver is a IR photodiode. These are sensitive to IR light of the IR LED. When object comes near to the sensor, the infrared light from the LED reflects off of the object and detected by the receiver. Circuit diagram. Figure shows the circuit diagram of IR sensor. IR sensor is having one IR LED and photodiode and a comparator. In this, IR LED acts as transmitter which emits the IR rays continuously when power is given to IR LED. These emitted IR rays are detected by the photodiode. Depending on the receiving of IR rays, IR output terminal of the receiver varies. This voltage variation cannot be analyzed. So, this output is given to the comparator circuit. When the IR receiver does not receive a signal, the potential at inverting terminal goes higher than the non-inverting input. Thus, the output of the comparator goes low. The LED does not glow. When IR receiver module receives the signal, the voltage at inverting input goes low, thus the output of the comparator goes high. LEDs start glowing. Simply we can analyze this one. Voltage of non-inverting terminal is greater than the inverting terminal, then the output of the comparator is positive. That means LED is glowing. If output of the comparator is negative, means inverting terminal output voltage is greater than the non-inverting terminal, LED will not glow. 330 ohm resistor is used for this LED. Now coming to the features of IR sensor. IR sensor is having IR LED as transmitter. In the range of infrared frequency, IR LED emits the light. IR light is invisible because its wavelength is much higher than the visible light range. IR LEDs having the light emitting angle of approximately 20 to 60 degrees. In some case, it will be in the range of kilometers. It depends on the type of IR transmitter and the manufacturer. IR LED comes in white or transparent in color so that it can give maximum amount of light. Coming to photodiode receiver. In IR sensor, photodiode acts as receiver. When the light falls on it, it conducts. Photodiode is a semiconductor which has PN junction operated in reverse bias. That means conducting the current in reverse direction when light falls on it, and the amount of current flow is proportional to the amount of light. This property of photodiode is useful for IR detection. Photodiode looks like a LED with black color coating on its outer side. Black color absorbs the highest amount of light. In IR sensor, for comparing the voltage, we are using LM358 op-amp. It is used as voltage comparator in IR sensor. The comparator will compare the threshold voltage set using the preset and the photodiode's series resistor voltage pin. Photodiode series resistor voltage drop is greater than threshold voltage, then op-amp output is high. If the photodiode series resistor voltage drop is less than threshold voltage, the output is low. When op-amp's output is high, LED will be turned on, means indicating that we are detecting the object. If the LED is not turned on, we can say that object is not detected. Here we are using variable resistor. Why we are using this variable resistors in IR sensor? This variable resistor used as a preset. It is used to calibrate the distance range at which the object should be detected. Coming to advantages of IR sensor. IR sensors response time is faster than thermocouple. This IR sensor provides good stability over time. The battery used in infrared devices lasts for long duration due to the lower power consumption. It delivers high repeatability. No corrosion or oxidation can affect the accuracy of infrared sensor. Moving to disadvantages of IR sensor. Infrared waves at high power can damage eyes. Means in IR sensor we are using infrared rays. Infrared at higher power, it can damage our eyes. It supports shorter range and hence its performance degrades with the longer distance. It supports lower data rate transmission compared to wire transmission. Infrared frequencies are affected by hard objects. Example, walls, doors, smoke, dust, fog, sunlight, etc. Hence, it does not work through walls and doors. Finally, the applications of IR sensor. Where we can use this IR sensor. These IR sensors can used in applied systems, transmission systems, optoelectric switch, infrared remote control equipment, smoke detector, in IoTs, industrial applications. In a coming lecture, we are going to discuss about interfacing of IR sensor with STM32F4 discovery board and its code demonstration. Thank you for watching.